Ever since the very first engine sputtered to life, we've been on this relentless quest for two things: more power and better efficiency, right? We want to go faster, haul more stuff, and use less fuel while we're doing it. But how do you get more bang for your buck without just building a bigger, heavier engine? Well, the answer is this incredibly clever piece of engineering that literally turns waste into pure power. You know, at its heart, any internal combustion engine is actually pretty simple. All its power comes from igniting a mix of fuel and air inside a cylinder. It's just a tiny, controlled explosion that pushes a piston down, and that's what ultimately turns the wheels. Simple enough, right?
So, if you want a bigger explosion for more power, you might think, easy, just add more fuel. But it's really not that simple. If you just pour in more gas without the right amount of air, you just get this smoky, inefficient mess. The critical thing to understand is that the fuel isn't the limiting factor here. The real challenge is something else entirely.
And here it is. The single biggest bottleneck for making more power in an engine is its thirst for air, specifically the oxygen in that air. See, an engine can only suck in so much air on its own, and that puts a hard ceiling on how much fuel it can actually burn effectively. And this is where all clicks together in this perfect little chain reaction. If you can force more air into the cylinder, you get more oxygen. More oxygen lets you have a much more complete and powerful combustion event. That better combustion creates way more power. And by getting more energy out of the same drop of fuel, you also improve efficiency. It is a total win-win-win situation. So how do we solve this air problem? With this thing, a turbocharger. Honestly, the best way to think about it is as a super sophisticated, self-powered air pump. It's designed for one job and one job only: to cram more air into the engine than it could ever hope to breathe on its own. The official definition is that a turbocharger is a device that uses a turbine and a compressor to force pressurized air into the engine. It's basically an air-forcing machine. But where does it get the energy to do all that work? And this is the truly brilliant part. It's powered for free. A turbocharger runs on the hot, high-pressure exhaust gas that the engine is already just throwing away as waste. It is one of the most elegant, clever examples of energy recycling in the entire world of mechanics. So to really get how a turbo works, you just need to think of it as two halves that are joined at the hip. You've got a hot side that deals with all the waste exhaust and a cold side that handles all the fresh air coming in. It's really a tale of two wheels. So on the left, you see the turbine. That's the hot side. Its job is to capture energy from the engine's exhaust. And on the right, that's the compressor, the cold side. It grabs fresh air from outside and pressurizes it. Okay, so let's follow the energy. The whole process kicks off the second the combustion happens. The hot, expanding exhaust gas, which just did its job pushing the piston down, gets forced out of the cylinder and is funneled directly into the turbine housing of the turbocharger. As this absolute torrent of hot gas rushes through that housing, it slams into the fins of the turbine wheel, forcing it to spin. And listen, we're talking about incredible speeds here. We're talking well over 100,000 revolutions per minute. Just try to picture a pinwheel caught in a hurricane. Now, this is the real mechanical genius of the whole device. That turbine wheel on the hot side and the compressor wheel on the cold side, they are locked together on a single shaft. They are one piece, which means if that turbine starts spinning, the compressor has absolutely no choice but to spin at the exact same crazy fast speed. So on the other end of that spinning shaft, the compressor wheel is acting just like a fan or a jet engine. It's sucking in huge volumes of fresh air, and because of the shape of its housing, it slings that air outwards, compressing it and building up a ton of pressure. So we've solved the problem, right? We've compressed the air, we're ready to shove it into the engine. Well, not quite. See, compressing the air actually created a new problem, and solving that problem is the turbo system's real secret weapon. It's just a fundamental rule of physics. When you compress any gas, its temperature goes way, way up. And what does hot air do? Like you see with this balloon, it expands. It gets less dense. And that's a problem, because less dense air has fewer oxygen molecules in it. We just worked really hard to compress the air, only to accidentally make it less effective for making power. And the difference is huge. The hot air coming straight out of the compressor is way less dense, meaning you get less oxygen into the cylinder. But if you can cool that compressed air back down, it becomes much, much denser. You can pack more air, and therefore way more oxygen, into the exact same space. And that is the key to unlocking maximum power. And this little guy is the hero that makes it all happen: the intercooler, or sometimes it's called a charge air cooler. It's basically just a radiator for your intake air. The hot, compressed air from the turbo flows through it, and cooler outside air flows across its fins, pulling all that heat out and making the air cool and dense again.
Okay, so we've looked at all the individual pieces of the puzzle. Now let's put it all together and follow the complete flow of air and exhaust through the entire system from start to finish.
And here it is, the whole shebang, the entire system in action. You can literally trace the path of every molecule, from fresh air coming in all the way to the powerful exhaust gas that drives this whole amazing cycle.
All right, let's just walk through it one last time. Step 1, fresh air comes in through a filter. 2, it gets sucked in and compressed by that compressor wheel. 3, the now super hot air is sent through the air cooler to get nice and dense. 4, this dense oxygen-rich air is forced into the engine cylinder. 5, it mixes with fuel for a big, powerful combustion. And finally, 6, the resulting exhaust gas flows out to spin the turbine, which of course starts the entire cycle all over again. What's so amazing about this is that it's a perfect self-sustaining loop. The waste exhaust gas provides all the energy to spin the compressor. The compressor forces more air in, which creates a bigger, better explosion. And that, in turn, creates an even stronger flow of exhaust gas, which spins the turbine even faster. It's just this elegant cycle of power feeding power. I mean, it's just an ingenious device that takes something completely useless, hot waste gas, and uses it to solve an engine's biggest problem, creating more power and more efficiency out of thin air. It really makes you wonder, what other amazing pieces of engineering are hiding all around us, just waiting in plain sight?